A very good morning everyone. Today we are going to present hydro turbine generator. Hydropower or hydroelectricity refer to conversion of energy from flowing water into electricity. It is considered a renewable energy source because water cycle is constantly renewed by the sun. One of the first uses hydro energy was mechanical mining such as grinding grains, but today modern hydro plants produce electricity by using turbines and generators. The mechanical energy created by moving water spins rotor on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dam and run-of-river. Hydro dams utilize the potential energy from dam water to produce electricity. A dam is a large barrier constructed to raise the level of water and controls its flow. The evolution created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pump storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still use turbines and generators but relies on natural water flow rates of river diverting just a portion of water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dam hydro. There are various sizes of hydro plants that produce electricity. Large hydro greater than 30 megawatts, small hydro 100 kilowatts to 30 megawatts, and micro hydro less than 100 kilowatts.
Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure inflow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. This produces electricity that can be stepped up in voltage through the station transformer and sent across transmission line. The falling water having served its purpose exit a generating station to the tail rest.
The water that comes from above flow through the penstock. For each penstock, there has its own head gate at the top to stop the water flow from maintenance or emergency cases. And for the end of penstock, there is a scroll case that occurs around the turbine. It is designed to create a consistent pressure water that entering the turbine from all the sides. There is a part inside the scroll case that we call wicket gates. These control how water flow into the turbine. The wicket gates are controlled by the external governor system. High load on the system slow the turbine, then the governor system reacts by opening the gate to speed it back. To get a low load response, it will narrow the wicket gates. As you can see, this is the part of the generator. From the top is exciter, which it gets a small DC power supply from cable to the automated voltage regulator. Below exciter is the generator. Inside generator, there is a rotor that are turned by the runner. And the outside part called stator, which it is made up of a set of 3 coils of copper that call winding. Back to the rotor. On the rotor, there is a number of electromagnets that are powered by DC current from exciter. The turbines will be able to spin without generate any electricity even when the switch are off. Each magnet poles on the outside create a separate rotating magnet. The magnets are lined up so that the poles always have opposite weak field, which north south, north south. When the rotor spins within the stator, each pole's magnetic field acts on the stator windings. Every time a pole makes one full revolution, one pulse AC power is generated in the windings and transmitted towards the grid attached to the stator. Because of the stator is connected to the grid, it is important that the pulses are in time with the grid frequency. So that when the pulses are in time with the grid frequency, the generator is in synchronized. System condition can push the stator magnetic fields out of sync with the rotor. The difference between the movement of the stator magnetic field and the rotor is the torque angle. The rotor part has a lot of electromagnet on it that produce a consistent flow of power. As shown there, the generator produce three-phase power by use different conductor to carry power generated with different part of stator.
Hydropower has several benefits. It is a cost-competitive form of electricity even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as a base load power. In some cases, dam reservoirs can also help with the flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the life of those living downstream. Hydropower plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement to use and plant matter in the flood areas make methane another greenhouse gas as it decays underwater. That's hydropower. That's all from us. Thank you.